Welcome to Fly with Physics students. So in this video we will be discussing about the inclined projectile motion. In the last lecture we have discussed about the projectile motion, that case in which the object is in the ground state, and then after some time after projectile motion it comes back to the ground. Okay, so there is net vertical displacement is 0 in that case. But in today's lecture, in this lecture we will be assuming the inclined plane here, and we will be projecting the object from the bottom of the inclined plane to up the inclined plane. Okay, so in that case what will be the time, what will be the horizontal range, and what will be the maximum height we will be calculating. Obviously these are not same in that case like we have discussed in the previous video, but some changes are there. We will see the changes, and then after that we will be concluding. We will also compare these from the previous ones, you say time of flight, horizontal ranges, and you say the maximum height also we will compare. But first of all we will be deriving that if there is a projection in the inclined plane, then what will be the analysis, okay, for time, for range, and for maximum height. Okay, so now let's get started. So first of all, now let us take the first case in which there is an inclined plane. See, this is the ground, and this one is the inclined plane here, having an angle alpha, and this is the another surface. Okay, now we have a ball here, or we have an object here, and object is fired from that place, and then after some time it gets hit to the point A. Now we have to find the time of flight for that O to A distance. Okay, and horizontal range also. This one is O to A, and one more thing, that is this maximum height. Okay, this is the maximum height from the from this plane. So first of all just you said define the axis. So this one is x axis, you see, and this one is y axis, you see. Okay, now after that we all know that the initial velocity of this object is u, and u makes an angle theta with this surface. This is the x1, so u makes an angle theta with x, and for example this is the theta. Now just resolving the u cos theta and u sin theta, so our ux becomes u cos theta and our uy becomes u sin theta. Okay, now talking about the acceleration part, so we have an acceleration part also. Every object, gravity is acting on downward. Yes, it is right, the gravity is acting like downward direction. So if we are taking the gravitational part, it means that acceleration due to gravity part, then it is acting downward. But if we resolve this acceleration for vertical and horizontal components, then what we will get? Now see how to resolve. First of all take a normal for that surface, on the surface, horizontal surface. This is the normal here, and we see that this angle is also alpha. For example, this is alpha, then this one is also alpha. Now why? It is because, for example, this is a triangle CO, you say this is P, you say this is Q. So OPQ is a triangle here. For example, this much is joined like that. Then after that, if this is alpha, then this one is 90. So this one becomes 90 minus alpha, and this is complete 90. So it becomes alpha. That is why this is alpha. Okay, so this one becomes g cos alpha for horizontal for vertical component, and then this one becomes horizontal component for g sin alpha, है ना? So if we just analyze this thing, then we notice that g sin alpha acts opposite to the u cos theta, and you say u sin g cos alpha is acts opposite to the u sin theta. What does it means? It means that the body is decelerating when it is traveling from O to A, from downward direction also, and from downward direction also, because g sin alpha is taking place as ax, and then g cos alpha is taking place at ay. Okay, so that is why we have taken minus sign here, because their directions are opposite to the direction of velocity. That is why nothing at all. So here ax is equal to minus g sin alpha. We got ax means acceleration due to x, due to x means due to horizontal, and here the vertical acceleration is g cos alpha, minus g cos alpha here. Okay, now just compare to the this case to the previous one case in which the ax is 0 and ay is u cos alpha, which is constant. It is also constant, no issue, but here the value is different, and here the ax is 0, where the ax is 0, here the ax is minus g sin alpha, this is non-zero. That is why we are saying that these are the different cases. Okay, so that is why we are not using the same formula like 2u sin theta by g is equal to t, we will be applying here, no. Okay, so now just calculating the time of flight and maximum height and horizontal range. Now we will see this is the time of flight. Time of flight in the previous case we have 2u sin theta divided by g, but now we will just derive. Now for derivation part we have v is equal to u plus at along the vertical direction. Now why we are applying v is equal to u plus at? Because here the acceleration is constant, acceleration acting on this system is constant. Why? Because g is constant, so alpha is also constant because it is not changing with respect to time, and at all the parameters it is not changing. So that is why we can say that g cos alpha is also constant and g sin alpha is also constant. So here the accelerations are constant, so we can use the speed equations. So that is why we are using speed equations. So according to these speed equations, v is equal to u plus at along the vertical direction, we can say that v along the y direction is 0. Why 0? Because for the complete journey from O to A, we are assuming from the time required for the body from O to A part, it is equal to t, it is equal to time of flight, this is tf. Okay, so in that case here when the body reaches at point A, the vx will equal vy is equal to 0. That place the you say the final velocity is 0, and then this one is uy, this one is ay, this one is t. So uy means u sin theta, ay means minus g cos alpha. Here you see ay is minus g cos alpha, है ना. So just put all the values of in vertical direction here, and tf for tf. So now just equating these all these, and after equating all these we will get the formula for time of flight, which is u sin theta divided by g cos alpha. Here you notice that here is g and here is g cos alpha, means g is just turned out to g cos alpha here. Okay, so this is all about the time of flight. Now coming to the next, which is maximum height. So when the body just is at this point, this point name is, for example, you say just take it t. Okay, no not t, because we have used t, we can assume it as q. Okay, this one becomes r. Okay, now okay, now see this point is q. At this point the object is not doing the vertical motion, it is doing as a horizontal motion at all, because at this point this is the highest point, and the object is not going upwards at all at this point. Okay, so that is why vy is equal to 0 in that case, but vx is not equal to 0. Vx we can formulate from u plus at formula. Okay, so according to that we can say that the vy is 0. We can use this one, so we can use this one in that derivation. So according to this, at the point q we will use the speed equation v square minus u square is equal to 2as. Why? Because here also the g is constant, so we can use this equation of motion. So at that point vy is equal to 0, so we will be putting vy is equal to 0 in this equation here, and uy is also uy is not 0, uy is u sin theta, and ay is g cos alpha, minus g cos alpha you are saying, है ना. So just put the value of uy and ay here, where uy is equal to you say u sin theta and ay is equal to minus g cos alpha. Just you have to put that in this equation, and here s is the vertical displacement at that point, and it is equal to height. So you got the formula for height, which is u square sin square theta upon 2g cos alpha. This is the answer. And you see that this is the previous cases answers, है ना. This is the previous case answer, and what is the difference between these two cases? Only and only g is substituted as g cos alpha, है ना. This is the main point you have to notice. So if you remember this one, first projectile motion, normal projectile motion case formulas, then you can automatically generate the formulas for inclined projectile motion. How? Just change the value of g to g cos alpha for time and height, only for time and flight and height, not for range. Why? Now we will see. Now see, for the range part, we have the old formula, है ना. For old formula, it is valid only for that case in which the body is starting from that point to that point at the ground, at the same, है ना. In that case, the formula for range is valid. But here the body is falling at the inclined plane, such that the inclined plane, the angle between the ground and the plane is alpha. Okay, so this is not about O to P, this is about O to A. And to calculate O to A, we cannot just substitute the value of g cos alpha rather than g in that case. Okay, so due to these complications, we can just derive the range first of all, and then after that we will be using. Now how to derive the range? This is the old method. That time we have also used this s is equal to ut plus half at square in horizontal direction to calculate the range. So s is equal to ut plus half at square, we will also do the same in the horizontal direction. So what we will get? Now see, in the horizontal direction, s is just this one range, which is OA. So we will take r, and u is in x direction, which is ux, which is equal to u sin u cos theta. Here theta is the angle between x axis and u, है ना. So this one is theta. Now see, now we have a tf also, and what is the value of tf? The value of tf is u sin theta divided by g cos alpha, and then after that plus 1 by 2 ax. What is ax here? Ax is minus g cos alpha, minus g sin alpha. We have minus g sin alpha. Okay, and then after that what is ax here? Ax we have already. Tf is u sin theta divided by g cos alpha whole square we have. Okay, now see what is happening here. You have r is equal to u cos theta, u sin theta, g cos. Just put all the values here, and you will get the formula for range. This is very complex, you need not to learn. You just you just do not learn first of all, and you just remember the derivation part. You just applied s is equal to ut plus half at square in horizontal direction, that's all. Okay, and just calculate it. Okay, so this is all about the range, maximum height, and the time of flight for inclined projectile motion, in that case in which the body is just released from point O and it goes to the point A. Now talking about the another case in which the projectile motion is there, but from the inclined plane to downwards direction. Okay, so here the body is here, and we projected out downwards from the inclined plane, and it strikes at this point A. Now what will be the r, what will be the h, what will be the t? Now we will discuss. Now see, in that case, first of all, just generalize all the things. First of all, this is u, and this is u cos theta, this is u sin theta. This one is x axis, this one is y axis, as same as that. This one is alpha, as same as that. G is acting downward as always, and then after that this one is g cos alpha, this one is g sin alpha. Okay, So here you see that u cos theta is in this direction, g sin alpha is also in this direction. So here the g sin alpha is plus. Okay, very good. Okay, now if we are talking about ay, if we are talking about ay is as same as g cos alpha, so it is minus g cos alpha here. Okay, so in the case of now time of flight and maximum height, there is no change in the formulas, है ना? Why? Because here the same thing is there. In you just use v is equal to u plus at, v is equal to u plus at here, v is equal to u plus at in horizontal direction, and no change is there. In the vertical direction, and no change is there. You will get the tf here, ay, here uy, here vy. So this one we have done. Similarly, if you want to calculate the maximum height, so you will use v square minus u square is equal to 2as, where in the vertical direction same, है ना? So in the vertical direction, this one is ay, this one is uy, this one is vy, this is 0, है ना? And then this one is u sin theta, this one is minus g cos alpha, and s is h. So you will get the same value h. But for the case of range, here you will use s is equal to ut plus half a t square, and this one becomes horizontal. If this one becomes horizontal, then you see that s is r here, and u is ux here, and t is this is the total time, this is time of flight, plus 1 by 2. Here ax is there, है ना? Ax, here ax is g cos alpha, which is positive, g sin alpha, which is positive here, है ना? But in the previous cases, see, in the previous cases the ax is minus g sin alpha, and the range is very big. This is this one, but minus sign here, है ना? But here you see, here in the projection in the downward planes, the sign is plus, ax sign is plus. So if ax sign is plus, now you see this one is at square, this one becomes u cos theta, this one becomes u cos theta, tf as same is u sin theta divided by g cos alpha, and this one is plus, this one is 1 by 2, this one is ax, which is equal to g sin alpha, and tf is same, tf is u sin theta and g cos alpha, है ना? u square sin square theta divided by g cos alpha, g square cos square alpha. Okay, so remember, this one is the range, and in the previous case this one is the range. Here in the up direction, if the projectile is moving in up direction up to the inclined plane, then the sign is minus, and if the projectile motion is in downward direction down the plane, then the sign is in plus. Okay, so you have to remember, if the projection is up the plane, then the sign is minus, negative, between, in the range, in the formula for range. And if downward direction is there, if the projection is downward direction along the inclined plane, then the sign for the range formula will be positive in between. Okay, you have to remember this, so that there will be no mistake. Okay, so there is a case for range. Okay, now we have calculated the time, we have calculated the maximum height, we have calculated the normal range, but what about the maximum range? How to calculate the maximum range? Now we will see. So maximum range, to calculate the maximum range, we will just put the idea as same as we have put in the previous video, that is dr by d theta will become 0, because the maximum point we have to take, है ना? So we have a range formula, and just derive this, just do the derivative, just do the differentiation with respect to theta, so that you will get the formula for you will get the theta also, and you will get the maximum range also. So now we have a range formula here. For up direction this one is positive, for down direction this one is negative. I think yes, for up direction this is positive and from down direction this is okay. ठीक है, then I think I have just take it opposite. Up is negative and down is positive. Yes, up for negative and down for positive. So this is the formula for range for both the cases. R is equal to u t f plus minus 1 by 2 a t f square. So up down case both are included. We will just calculate the maximum range. So how to calculate the maximum range? Just take the minima for this maximum range with respect to theta, because theta is changing, because alpha is constant here at all the points, है ना. So that is why dr divided by d theta, just equate it to 0, and it is very tedious calculation, and just I am finalizing the main answer. The maximum range will be come out to be r max is equal to u square upon g 1 plus sine alpha. Okay, here plus here the sign will be changed I think, है ना. Yes, for the positive sign the projectile for the plane, and you will take a negative sign for the downward motion. Okay, means the original signs are changed at this point. So this is for maximum range. ठीक है, so you have to remember this formula. Just go through dr by d theta is equal to 0 after putting all the values for this, and then after that you will be seeing that this formula will become the most priority for that type of question. Okay, so this is all about the maximum range. So I think that's all for today's class. So if you have any doubt regarding these topics, you will just comment below. I will see as soon as possible, no issue. And share the session please. If you are taking any benefit for these classes, then please share, and we will also cover some more topics. Please comment me if you want that this topic must be included first, and then we will see. Okay, please subscribe, and thank you very much.